Hey, this is Jeremy with information on the test fixture. In this video I'm going to go over the Q programmer and what's involved to make the motor actually go and do the testing. So looking at the computer, the first thing that needs to be done is you need to get the Q programmer software. To do that, this is the Applied Motions website. This is our driver right here that we're using, and so the programming that's involved to use it is called Q Programmer. If you go down below this and under software, you will find Q Programmer here. This is a download. Download that and install it just like you would any other program, and it'll install on your computer. Then we can go and run it once it's installed. And this is our interface screen for the Q Programmer. And so this is how we communicate with the controller to make it do what we want to do. So first what we have to do is hook it up to the controller and have it communicate. You can see there's no status, no polling, there's a communication error. That's because it's not configured right. Two things we have to do quickly. We have to change it to RS-232-485, saying it's going to use a port on the computer rather than an Ethernet connection. Then we need to specify the serial port. To find the serial port, if you're not sure, to go through that quickly, you just go to the control panel and then you go into the device manager, and that needs administrative privileges to go into this, so we need to allow that. And then we go to the ports, and right here this ports will show what ports are being used by peripherals, and this shows we have our USB to serial COM, which is installed, and that's using COM3, so we know we need to specify that to COM3. So then we come back to the Q programmer and we specify the COM3, which probably is going to be the only one if it's there, but you may have multiple, and that's why it's good to know which one that is. Once we select that, then it will get the communication going. Also, as before we do this, you do need to have it powered on, so it is plugged in and going, and you need the light blinking. The light flashing just means it's ready to go. There's no error codes or anything that's going on. And just for information, all the error codes are listed on the controller itself based on the red and green LEDs that can flash there. So we want to have that turned on, and then when you configure your communication here, we'll get the communication to go. Okay, so now it's communicating, we're all set up here. Now we need to open the program, and I just have a program here called Blind Tester, configured to do what we want it to do. And so once it's loaded up in here, it'll bring it into this what's called the segment, and we're just using the very first part of segment 1, and that's all we need. And then to actually push this to the controller to be able to run it, we need to say download program, and then you'll see all the information jump into the command script. It'll say it's complete. Now we're ready to execute. So then all you need to do is say execute program here, and as soon as this happens, it'll start running the program. So we'll say execute, and you can see now it's running through the program. And the program is just set up to have the pulley go spin back and forth to simulate turning the shade up and down, and it'll just go over and over as many times as you want it to go. And that's what we'll look at configuring here. So at this point, we can look at the different information values. We'll just go through these quickly. I'll get more text documentation to refer to all of these. We have our acceleration values at the very top. So this is acceleration, deceleration. We have these set to 5. This is 5 revolutions per second squared, and so 5 is actually a pretty low number. We'll probably want to do something higher than that. Velocity, this is 3.5 revolutions per second. This equates to right around 2 feet per second. So this is our upper limit that we have it at right now. 2 feet per second. This is our distance. Distance is 15,000. The way that this works is it uses the number of steps in the motor, and there's 4,000 steps per revolution. So right now it's doing 15,000 steps, or just under 4 revolutions, 3 3/4. And so this is our distance, or how far it's going to go on each time it turns a certain direction. We have a wait time here. This wait, we have a quarter second after it turns. It's going to wait a quarter second, and then it's going to minus 15,000. And so basically we just want to make sure that these two values are the same. So it turns one direction and then goes back the other direction. And then we've got another wait time hereafter. After each cycle it'll wait a little, just however long we want it to wait. And then we've got the counter here. This is our counter out here. This is the number of cycles it's going to do. We've got it set to 50 right now, but we can put that at anything we want. And then finally we have our data monitor under show data monitor, and this gives us the data about what's going on. And so here, this user defined is our counter, and this shows us what cycle we're on. Right now we're on 33, 34, and you can see every few seconds it goes. Every time it goes up and down, it counts that as a cycle. And so we've got it going up to 50 right now, but we can see, for instance, if you have it going to 10,000 cycles over a few days, you can check on it each day and see exactly what cycle you're on and how far along you are. Another good piece of information that I have configured here is the current. This just kind of shows how much current is being used. This is electrical current by the motor. Right now we have no load on it, so we have really low values. These are, I believe these are millivolts. But really what we want to use this for is to see if there's any change in the current over the life of the test. At the start, looking at the first, say, every day you probably want to take a look to see if the current is changing over the first 1,000 to the 5,000 to the 10,000 cycle, to see if there's more stress or more resistance in the clutch. And so that's just a good piece of data. And to look at these, you can pick on these, and these can be configured to many different pieces of data that can be acquired from the system, but really the only ones that are important to us at this point is the current. So that's just kind of a quick overview of controlling the system, and I'll get information put together of details on all the values within the program itself.